section R.5, the basics of equation solving. We'll actually look at some of these techniques again later on in Chapter 1 as well as Chapter 3. Some definitions. We make these definitions just so we can talk to one another. I'm not going to ever ask you to repeat definitions, but you do need to know what the definitions are. So definition. A solution to an equation is a value which, when substituted into the equation, makes the equation true. A mathematical equation is actually a conditional statement. It's waiting for you to give it a condition, namely the value of x, to determine if it's true or false. Now, if the equation is true from the solution, we say that the solution satisfies the equation. The set of all solutions to an equation is called its solution set. When giving the solution set to an equation, you must enclose the values in braces. Remember, braces are used for sets. For example, if x is equal to 2, its solution to your equation, the solution set would be given as the set that contains 2. I usually ask you just to solve for x. That way you write x equals a number, you just write down the number. A solution that fails to satisfy its equation is called an extraneous solution. An extraneous solution is not the result of an error. You have done nothing wrong, but this value appears and it will not work. Later on we'll have certain types of equations in which you must in fact check your solution to see if it really does work. Whenever that happens, I'll let you know what's the clue that you're supposed to check and what's the clue that lets you know it's an extraneous solution as opposed to an error, because after all, a mistake is not going to work either. Definition. Equivalent equations are equations that have the exact same solution sets. Now, equivalent equations don't have to be equal, but of course if the equations are equal, they will have the same solution sets. As an example, x plus 3 equals 5 and 7x equals 14 have the exact same solution sets, namely the set that contains 2. So these are equivalent equations, but they really don't look anything alike. Definition. To isolate a variable means to get that variable with exponent 1 and coefficient 1 on one side of the equation and everything else on the other side of the equation. When isolating a variable, that variable is not allowed to appear on both sides of the equation. And you can't have like x equals something else about x, because that would mean if you tell me what x is, then I'll be able to tell you what x is. So our goal in solving equations is to turn the original equation, the problem that's given to you, into an equation that looks like this. X equals a number. Notice that x has exponent 1, coefficient 1, and a number is everything else, and it's on the other side. So this is an equation that has isolated the variable x. So our goal in solving equations. With our definitions, we can now precisely state the goal in solving equations. Our goal is to isolate the variable while maintaining equivalent equations. It's the maintaining equivalent equations parts that's actually kind of difficult. Excuse me. We want to make sure that everything we do does not lose any solutions. If we pick up solutions, we can always check those, but we don't want to lose any. So to accomplish the goal, we're going to need equation solving principles. Now, depending upon how you have them, we could have several equation solving principles. We're going to see most of them actually in this section. So there are several equation solving principles. For now, we're going to look at only 2 of them, and then we'll take a look at a couple more. So, the addition principle. The addition principle states if an equation equals b is true, then a plus c equals b plus c is also true for any value c. Basically, you're allowed to add the same thing to both sides of the equation. That's all it's saying. You can add the same thing to both sides of the equation. Oftentimes in algebra, you'll wonder, am I allowed to do this? And the answer is, if you do it to both sides, yes, you can. The real question is what you're doing useful? So there's no such thing as a subtraction principle, even though we will say something like subtract 4 from both sides, since subtraction is really the addition of a negative number. So to subtract 4 from both sides really is the same thing as adding minus 4 to both sides. Now, some books do talk about a subtraction principle, but we won't. Okay, so the addition principle takes care of adding a negative number for the subtraction principle. Before doing some examples, we're going to look at everything about this, and then we'll look at the other principle. So facts about the addition principle. The addition principle always produces equivalent equations. Okay, always. It is used to, number 1, remove expressions that are added to or subtracted from the variable. Its second use is to combine similar terms. Those 2 are actually the same thing, they're just cleverly disguised versions of each other. The multiplication principle. Okay, the multiplication principle says if a equals b is true, then ac equals bc is also true for any value c not equal to 0. So the multiplication principle says you can multiply both sides of the equation by the same non-zero number. Don't multiply both sides by 0, because anything times 0 equals 0. And we'd have 0 equals 0, which is always true, even if the original equation was entirely false. So again, never multiply an equation by 0. You're saying, well, I would never do that, but you throw in enough variables and you might do it without realizing it. So there's no such thing as a division principle, even though we might say divide by 4, since division is multiplication by a fraction. Dividing by 4 is the same thing as multiplying by 1/4. Now when we say divide, we really don't mean divide. What we really mean is write the fraction and reduce it. Facts about the multiplication principle. Okay, warning, the multiplication principle does not always produce equivalent equations. So that means sometimes you have to check your solutions. Now again, the times when you have to check your solutions, I will let you know. It's not going to happen right away, but it will eventually happen. That means on certain occasions, we will need to check our solutions. Again, I will let you know what will require you to check your solutions when we encounter those occasions. For now, it is not necessary for you to check, unless of course you just want to. The multiplication principle is used to, number 1, remove expressions that multiply or divide the variable. Its second use, it's used to clear fractions. We can get rid of fractions in an equation. Again, those two are actually equivalent to each other. They're cleverly disguised versions of each other. Now, if you have a fractional expression, no equation, you're stuck with living with it. But with equations, you can make the fractions go away. Now, if the answer, the solution, is in fact a fraction, it will come back. But when we're down to the solution, it doesn't matter because we're done. Some examples. Solve for x, simplify your answers, do not use mixed numbers or decimals in your answers. Okay, this is kind of my standard directions for solving equations. Okay, our first one, I've got x minus 9 equals 6. Okay, hopefully you can see what it is you're supposed to do, but the idea is you add 9 to both sides. You know, sometimes, I was always taught, instead of adding 9 to both sides, we say move the 9 to the other side, and when it moves to the side, it changes sign, like it's negative on this side, when it comes on this side, it becomes positive. So here we are, I'm going to add 9 to both sides. On the left, minus 9 plus 9 is 0, so I'm going to end up with x, and this side I get 15. So x is 15. There's your answer. Number 2, I have x plus 15 equals 9. Okay, we need to subtract 15 from both sides. So, subtracting 15 from both sides. On the left, 15 minus 15 is 0, and on the right, 9 minus 15, I get negative 6. Okay, as time goes on, I will stop writing this down. If you want to keep writing it down in your work, that's fine. I'll say what we're doing, but I will eventually just stop doing that. Number 3, I have 3x equals 21. Okay, I've got 3 multiplying the x. I want to do the opposite of that, so divide both sides by 3. So on the left, the 3's cancel, and on the right, 21 over 3 is going to be 7. So I'm simplifying to get x to equal 7. Again, with division, we will say the word divide, but really what we mean is write the fraction and reduce it. Number 4, I have 5x minus 7 is equal to 18. Okay, I want to get x by itself. So the first thing we're going to do is going to add 7 to both sides. So 18 plus 7, I get 25. Now to get rid of the 5 that's multiplying the x, divide by 5. So 25 divided by 5 is 5. I got x is 5. Number 5, I have 3 times 8x plus 14 equals 11. You know, according to my dear Aunt Sally, we're supposed to what's in parentheses first, but the terms aren't similar, so I cannot combine them. So I'm going to distribute the 3. So I'll have 24x plus 42 is equal to 11. Okay, now it has the same form as number 4, so we'll subtract 42. So I'll have 24x equals negative 31. Now we divide by the 24. And again, just write the fraction and reduce it. So x will equal negative 31 over 24. Okay, it is reduced. Now the minus sign, it doesn't matter if you leave it in the numerator, put it in front of the fraction, or put it in the denominator. But again, we prefer to have it either in front of the fraction or in the numerator. We really don't like negative denominators. Number 6, I have 4x minus 12 plus 7x is equal to 3x plus 10. Now before we start moving stuff around, on the left-hand side, I can combine those x terms. So the first we're going to do is combine similar terms. I'm going to combine the 4x and the 7x. So the 4x plus 7x, I'm going to get 11x. So my left-hand side becomes 11x minus 12. Right-hand side stays the same. Okay, now I want to move x's to the left, numbers to the right. Okay, I actually have a bias of moving x's to the left. You can move them to the right, but I prefer to move them to the left. That way you can say x equals something. So get x's on one side of the equation and numbers on the other side. Again, I prefer the variables on the left. So add 12 to both sides to to get rid of the 12 here, and subtract 3x from both sides to make this 3x go to the left side. So when we do that, we end up with 8x equals 22. Again, 11x minus 3x is 8x. 10 plus 12 gives me 22. Divide by 8. When I have x is 22 over 8, I can reduce that. They're both even. It reduces to 11 over 4. Again, don't go to a mixed number. Remember the directions said do not use mixed numbers or decimals in your answers. Number 7. Okay, I've got fractions in the problem. I've got 3/4 x minus 1/2 equals 7/8. Okay, my LCD is 8, which is 8 over 1. I want to clear of fractions, so I looked for a common denominator for 4, 2, and 8. I'm going to multiply every term by 8. So I'm multiplying by 8 over 1. Everybody, I've shown that in red. Okay, now we do some canceling, right? 4 goes into 8 twice, 2 goes into 8 4 times, and 8 goes into 8 itself once. So I'm going to have 6x minus 4 equals 7. Okay, now remember, these new numbers came from multiplying each term by 8. Okay, now the numbers got bigger, but the fractions are gone. Okay, now we add 4 to both sides. So I have 6x equals 11. Now we divide by 6, so x is equal to 11 over 6. The fraction is reduced. Again, don't go to a mixed number, don't go to a decimal. Okay, number 8. We've got 2/3 times 7x minus 8 plus 5/6 is equal to 5/4 x minus 4. Okay, I've got fractions and I've got parentheses. So I'm going to clear fractions. That's always going to be my first step. Now, when you're clearing of fractions, do not go inside parentheses. You're not distributing yet. You're trying to make these fractions go away. Remember, this 4 is secretly 4 over 1. I want to get a common denominator for 3, 6, and 4. Okay, it's actually 12 is my LCD. So again, multiply all the expressions that are outside parentheses by 12, including the 4. Do not go inside parentheses when you're clearing of fractions. So there I'm multiplying by 12 over 1 for everybody. Okay, do your canceling. 3 goes into 12 4 times. 6 goes into 12 twice. 4 goes into 12 3 times, and I don't need to do any canceling there. So I'll have 8 times 7x minus 8 plus 10 is equal to 15x minus 48. Again, all of the numbers outside of parentheses were multiplied by 12. Do not go inside parentheses when you're clearing of fractions. Now we're ready to distribute the 8. So I'll have 56x minus 64 plus 10 is equal to 15x minus 48. On the left-hand side, I can combine negative 64 plus 10 to get negative 54. So I have 56x minus 54 is equal to 15x minus 48. Again, I want x's on one side, numbers on the other, so I want to move x's to the left, numbers to the right. So subtract 15x, add 54. So when I subtract 15x and add 54, I get 41x equals 6. So again, I added 15x, subtracted 15x, added 54. Now I divide by 41. So x will be 6 over 41. It is reduced. Problem number 9. I have 4 times 2x minus 3 is equal to 6x plus 2 times x minus 5. Okay, no fractions to worry about, but I got to distribute the 4, I got to distribute the 2. So I'm going to have 8x minus 12 is equal to 6x plus 2x minus 10. Okay, now on the right hand side, combine 6x and 2x. So I have 8x minus 12 equals 8x minus 10. Come on, get x's on the left, numbers on the right. So subtract 8x, add 12. Okay, so 8x minus 8x will be 0. 12 plus 10 will be 2. So I have 0 equals 2. Okay, notice there are no variables, but I'm left with 0 equals 2. This is not true. Okay, 0 doesn't equal 2, not even for small values of 2. So I arrived at a statement that's clearly false. That means no solution. And that's what you write as your answer, no solution. Don't write false, write no solution. Number 10. I have 4 times 2x minus 3 equals 6x plus 2x minus 6. Okay, again, I got to distribute the 4 and distribute the 2. So I have 8x minus 12 equals 6x plus 2x minus 12. I have to combine the 6x and the 2x. So that'll give me 8x. Well, 8x minus 12 equals 8x minus 12. Now I'm going to move x's to the left, numbers to the right. So subtract 8x, add 12. 8x minus 8x will give me 0. Negative 12 plus 12 gives me 0. I have 0 equals 0, which is always true. 0 always equals 0. I've arrived at a statement that's always true. Whenever that happens, that means the solution is all real numbers. Okay, so that's your answer, all real numbers. Don't write down true, it's all real numbers. Notice 9 and 10 were kind of weird cases. 1 through 8, there was just one solution, but 9 and 10, something weird happened. So, the pathological cases. Examples 9 and 10 illustrate the two pathological or extreme cases in solving equations. Number 1, if you arrive at a statement that is clearly false, like the 0 equals 2, then there are no solutions. And that is what you should write on test. Also for homework, no solution. Now in my math lab, sometimes it will ask you to write a capital N. If there's no solution, the capital N stands for no solution. Number 2, if you arrive at a statement that is clearly true, the solution is all real numbers. And that is what you should write on test. Solution is all real numbers. Now sometimes in my math lab, you'll actually have that as a radio button, just like you'll have a radio button for no solution. Sometimes in my math lab, it'll ask you to write capital A, standing for all real numbers. So in my math lab, read the directions carefully. Also on the test, read the directions carefully as to what you're supposed to do for answers. So again, remember, if you arrive at something that's false, that's no solution. If you arrive at something that's true, that's all real numbers. Let's take a look at another equation solving principle. The principle of zero products. This will come back to haunt us in Chapter 3. So we'll look at a method that is used to solve equations that have an exponent larger than 1 on the variable. Just like you have an x squared, an x cubed, an x to the fourth, and so on. The principle of zero products. It says if a times b is equal to 0, then either a equals 0, b equals 0, or a and b both are 0. It's also called the zero factor property. If you think about it, you've multiplied two expressions and got 0, that means one of them had to be 0. Same thing, you can multiply 3 expressions by 0. One of them had to be 0. Just remember, 0 times anything is 0. So the principle of zero products used to solve almost every type of algebraic equation and many non-algebraic equations except for the linear equations. Okay, the linear equations are the ones that have exponent 1 on the variable. Remember, that was the linear term. So it's kind of like the linear equations are the exception to the rule. All the others are going to follow what we describe here for using the principle of zero products. So its most important use for us will be to solve ax squared plus bx plus c equals 0. If you remember previously, we looked at factoring ax squared plus bx plus c. So it's going to involve your factoring techniques. This is our first application of factoring, solving equations. So using your principle of zero products. Step 1, set the equation equal to 0. Now oftentimes this is done for you, but it isn't. Do that as your first step. Set the equation equal to 0. Also contained inside of this is write the equation in correct order, decreasing powers of x. Make it look like ax squared plus bx plus c equals 0. Step 2, factor. This is where the work is. Doing your factoring. You have to drag in all your factoring techniques. Step 3, set each factor equal to 0 and solve. This is where you're actually using the principle of zero products. Remember, you have something times something is 0. That means one of the factors is 0 or both of the factors are 0. Again, we use principle of zero products to solve all algebraic equations that have an exponent larger than 1 on the variable. So if you see like an x squared or an x cubed or something in the equation, you're going to set it equal to 0 and start factoring. Some examples. Solve for x. Simplify your answers. Do not use mixed numbers or decimals in your answers. Again, the usual directions that I have. Here's our first one. I have 5x minus 3 times 2x plus 11 equals 0. Notice it is factored for us, and it is already set equal to 0. So steps 1 and 2 have already been done for us. So now we're at the stage of setting each factor equal to 0 and solve. So I've got 5x minus 3 equals 0. See, we're going to add 3, divide by 5. So x is 3/5. Okay, now the other factor, 2x plus 11 equals 0. Subtract 11, divide by 2. X is negative 11 halves. So our solutions are 3/5 and negative 11 halves. Okay, just put a comma between your separate answers. In my math lab, it'll also say that. Put commas or separate your answers by commas. Now in my math lab, be very, very careful. Make sure the comma is between the fractions. Don't put the comma in the denominator. It'll be marked wrong. You don't put commas in denominators. don't put the comma in the numerator. It'll also be marked wrong. Okay, commas are not put in numerators. They're put between the two fractions. Number 2, I have x squared minus 5x minus 6 equal to 0. Okay, it is equal to 0. It is in correct order. So I need to factor. I need to find numbers whose product is negative 6 and whose sum is negative 5. It looks like 1 and negative 6 works. Okay? So now we're going to see each factor equal to 0. So I have x plus 1 equals 0. So x is negative 1. I have x minus 6 equals 0. So I add 6, so I get x is 6. So our solutions, negative 1 and 6. Okay? Don't put any decorations around them. Okay, it just said solve for x. That means x equals a number. In my math lab, if he wants a solution set, he puts the braces there for you. You don't have to make them. He puts the braces for you. Don't put them in parentheses. That makes it an interval. Don't put it in brackets. That makes it an interval. It's just negative 1, comma 6. Number 3, I have 2x cubed plus 4x squared minus 16x equals 0. Okay, it is set equal to 0. It is in correct order. So now we have to do some factoring. Looks like all the numbers are even, and everybody has an x. I can factor out 2x. That'll leave me x squared plus 2x minus 8. Okay, now I want to factor some more. Multiply to be negative 8. Add up to be 2. Looks like 4 and negative 2. So 2x times x plus 4 times x minus 2 equals 0. I have it factored completely. Okay, so each factor equals 0. Don't forget the 2x. So if 2x is equal to 0, okay, divide by 2. 0 over 2 is still 0, so x is 0. The next factor, x plus 4 equals 0. Subtract 4. X is negative 4. The last factor, x minus 2 is equal to 0. Add 2, x is 2. So our solutions are 0, negative 4, and 2. Okay, the order in which you write the answers doesn't matter. Just be sure you separate them by commas, and again, if they are fractions, make sure the commas are between the fractions, not in the denominator or not in the numerator, but actually between the fractions. And again, if my math lab wants a solution set, he will put the braces. You don't have to make them. Don't put these in parentheses. Do not put them in brackets. Just leave them alone like that. Number 4, I have x minus 5 times x plus 4 equals 10. Okay, unlike the first example we started with, this one, even though I have a factor, it's not set equal to 0. That means I do have to FOIL out the left-hand side, set it equal to 0, and then try to refactor it. So let's do FOIL on the left-hand side. So I've got x squared minus 5x plus 4x minus 20 equals 10. Okay, combine the outer and the inner. That'll give me x squared minus x minus 20 is equal to 10. Subtract the 10. Remember, I want it set equal to 0. X squared minus x minus 30 is equal to 0. Okay, now we try to factor again. I want numbers that multiply to be negative 30 and add up to be negative 1. Looks like it's going to be minus 6 and plus 5. Okay, set each factor equal to 0. X minus 6 equals 0 gives me 6, and x plus 5 equals 0 gives me negative 5. You may have noticed it's the opposite of the number you're looking at. This was a minus 6, you put down 6. This was a positive 5, you put down negative 5. Okay, oftentimes, again, we're going to go from this step to this step, and we'll do it mentally. You know, what makes x minus 6, 0? 6. What makes x plus 5, 0? Negative 5. Let's try another. I have x times 2x minus 1 equals 1. Now, again, it's factored, but it's not set equal to 0. So I have to distribute the x. So distributing the x gives me 2x squared minus x is equal to 1. Okay, I've got to set it equal to 0, so subtract 1 from both sides. Okay, now we could split the middle term, but that could be kind of painful. For 2x squared, it's got to be 2x and x, and for 1, it's got to be 1 and 1. It's a matter of getting the signs right. Okay, now, will this give me a minus 1 in the middle? Let's see, minus 2x plus 1x does give me minus x. Okay, set each factor equal to 0. 2x plus 1 gives me negative 1/2, right? You subtract negative 1, divide by 2. X minus 1 equaling 0 gives me the 1. Okay, let's take another equation solving principle. We will also see this next equation solving principle in chapter 3 as well. The square root principle. This is what it says. The square root principle states the following. Let capital X be a variable expression, you know, like x plus 5 or something, and let a be a non-negative real number. Okay, non-negative includes 0, by the way. Then, if capital X squared equals a, so you got something squared equals a number. we can take square roots of both sides of the equation to get this. The square root of x squared is equal to the square root of a. Simplifying gives us two answers. Capital X is plus or minus the square root of a. Because after all, think about it. 4 and negative 4 will square to give you 16. 5 and negative 5 will square to give you 25. So don't forget the plus or minus. You have to physically remember to put the plus or minus. Now, this is kind of backwards in the arrangement of our book. You're also expected to simplify the square root. By the time we're done with Chapter R, you will know how to do that, which means when you take the test on Chapter R, you'll have to simplify using the square root principle. So, warning, do not forget to put plus or minus on the right-hand side after you take square roots. Now, in my math lab, there is no way to write plus or minus. You actually have to write down two answers, the positive square root, comma, negative square root. Let's try some examples. Solve for x. Simplify your answers. Do not use mixed numbers, no linear answers. So, again, the usual directions. Here's our first one. X squared equals 25. Okay, I have something squared equals a number. So, we're going to take square roots. On the left-hand side, we get x. And on the right, the square root of 25 is 5. Now, don't forget the plus or minus. So, x is equal to plus or minus 5. Or if you separate them, 5 comma negative 5. Again, no decorations around them. Just leave the numbers alone. Number 2, x squared equals 17. Okay, again, we have something squared as a number. So, we take square roots. On the left, we get x. On the right, plus or minus square root of 17. Okay, now 17 is not a perfect square, so we leave it. Okay, now in my math lab, you will have to do this. You will have to put square root of 17, comma, negative square root of 17. 17 is not a perfect square. Don't approximate it. Okay, the directions say anything about approximating, so don't approximate. Just leave it alone. Number 3, I have 3x squared equals 21. Okay, it almost looks like the other two except for this number 3. So first, divide by 3. So I'll have x squared equals 7. I now have something squared equals a number. Take square roots. On the left-hand side, we get x. On the right-hand side, plus or minus square root of 7. The common thing that goes wrong is students forget the plus or minus. So again, two separate answers in my math lab. Separate them by a comma. Make sure when you put the comma in my math lab, make sure you're not under the radical. The comma does not go under the radical, just like the comma does not go in denominators, the comma does not go in numerators. It also does not go under square roots. Okay? Number 4, I have x minus 5 squared equals 14. Okay, now if you're thinking about squaring out x minus 5 and subtracting 14 and trying to factor, it won't work. Okay? It won't factor. It's just not going to factor. But I do have something squared equals a number. My something happens to be x minus 5, but that's okay. So we're going to take square roots of both sides. Okay, the left-hand side will become x minus 5. The square root gets rid of the square. Okay, the right-hand side will become plus or minus square root of 14. Okay, now 14 is not a perfect square. Okay, to get x by itself, just add 5. Now, when we put the 5, put it in front of the plus or minus. Don't put it out here in the end. Put the 5 in front of the plus or minus. So I'll have x is equal to 5 plus or minus square root of 14. Or if you separate it into two answers, 5 minus square root of 14, 5 plus square root of 14. Again, put the number before the plus or minus. Put it before the plus or minus. And let's take a look at one more. I have 6 times x plus 3 squared equals 30. Okay, this almost looks like number 4 except for this 6. So the first thing we should do is divide by 6. So I'll have x plus 3 squared is equal to 5. And now it looks like number 4. Take square roots of both sides. The left-hand side, the square root gets rid of the square. On the right-hand side, you have plus or minus the square root of 5. To get x by itself, subtract 3. And again, the minus 3 is going to go before the plus or minus. Put the numbers before the plus or minus. Don't put them on the end. So if x is equal to negative 3 plus or minus square root of 5, or here it is separated as two answers. Please don't factor out a negative or anything like that. Just leave it alone. Now again, the square root principle and the factoring, we'll see them again in Chapter 3. The linear equations, we'll see them again in Chapter 1. That's the end of Section R.5.